I'm joined now by Reenst Lesemann of Columbia Power Systems, and you're based where?
The company is based in Corvallis, Oregon, and we also have an office in Charlottesville, Virginia.
And you are the CEO?
Yes, sir.
And you're an engineer by training?
I am not.
You're not an engineer?
I'm not an engineer, which, as I like to say, means I'm not encumbered by the facts. But no, most of our engineering team is in Corvallis, Oregon.
Ah. And what is your own discipline?
Business. So I was actually a history major in college.
Well, that's interesting.
Yes.
Whereabouts in development is your project, or is your technology, is a better way of asking?
Yes, so our device, we just completed a 13-month sea trial of a mid-scale prototype. That prototype was located in Puget Sound, very near Seattle. We chose that site. It's actually one of the few sites in the U.S. where we could find an environment, a mid-scale environment that actually mimicked an open water environment. So this is a mid-scale device.
And yours is a wave device.
It is an offshore wave device, yes.
And explain very quickly, if you can, how it works.
Sure. It's a fiberglass structure. There are two wings. There's a wing forward side that is wave facing, and then there's a wing in the stern, and then there's a cylinder in the middle that holds the generators and the power electronics and the other equipment. And as each swell comes to the device, each of the wings is moving with the contour of that wave. The device itself, that cylinder, is actually moving in a rotary fashion. And so what we're trying to do is exaggerate the motion between those three bodies to turn our generators back and forth.
How is it affixed to the ocean floor?
It's moored. It's not a tight tether or anchor. It's loosely moored. It's really for station keeping. We have used a 3-point mooring, but we're moving towards a single-point mooring. We actually announced a contract yesterday with Intermore, an oil and gas mooring system design firm, and so we're trying to drive costs out here. So we've actually moved to a single-point system.
How are you affected by tidal rise and fall?
It doesn't really affect, because there's enough slack in the mooring system line that, again, it's station keeping. So whether we're up 6-10 feet or down 6-10 feet,
it can deal with rises of that much,
yes,
which you don't get really in the central part of the United States, but you do on the further north.
That's right, and you know, we're dealing with that sort of vertical change with every passing wave. So whether it's a 25-foot or a 6-foot or a 50-foot wave, I mean, we're already dealing with that extreme.
Ideally, does this device rise to the top of the wave? Is it on the surface of the wave?
It is on the surface, yes.
But it doesn't matter the wave goes over it, which is going to happen from time to time.
That's right.
Presumably.
Sure. We'll be overtopped in certain situations.
Each device, what will the power output be?
Yeah, so that's a great question. So with the initial device, it obviously depends on the resource, but we're looking for anywhere from 1.3 to 2 gigawatt hours a year as we progress forward. It's very volume dependent as we make advances in our output. We think at the end of the day we'll be much closer to 3 to 3.5 gigawatt hours a year per device.
And who are the customers? Is this meant to feed into electric grids, or is it going to be dedicated to remote installations? What is the planning here?
Yes, so the market for us is concentrated utility scale power plant. So yes, we are looking for large scale 1,500.
And it lends itself to base load.
Absolutely, yes.
So eventually you would have a series of these wings? Or would they be mounted in sequence, or would they be just one in each installation?
Each device is independent. So we would have a farm, an array, just as you would see with the wind farm. So it's a multitude of devices. So it really depends on what is the capacity of the farm and what the offtake would be. We're not trying to be project developers. We're trying to be the manufacturers of the devices. That's where our core competency is.
When do you think you'll achieve some sort of commercial maturity that you can offer power to the grid?
We would love to be able to have our first in-the-water beta test, so to speak, in the 2014 timeframe, and then very soon after that would like to be in a position to offer commercial kits for sale.
Are you you said commercial kits?
Yes.
So people are going to assemble these themselves?
No, a kit, I guess I'm borrowing a European term there, which means the whole mooring system, the infrastructure, and the device itself.
And they will be manufactured in the US or overseas? Or?
Well, they tend to be manufactured, because they're large devices, they tend to be manufactured fairly close to where they're deployed. It's one of the reasons why we like the fiberglass, because it's a winding technology. It can really be set up anywhere in the world. So
would you be using the same factories that make them for windmills?
So the generators will be made by an OEM, by a partner, and wherever their manufacturing is. So large pieces of the structure will be manufactured remotely, but there will be exports out of the U.S. just as there might be exports out of Europe or so forth.
Is yours a freestanding company, or is it part of a larger company? Is it a subsidiary?
Freestanding company.
And is it privately held, or is it?
It is privately held.
And how long have you been going?
So the company was first formed in 2005. It was originally a partnership with Oregon State University, where we were hiring graduate students from there to work on the engineering. In about 2008, 2007, 2008, those engineers started to work their way over and be hired directly by the company. It's why we're in Corvallis, and that is where the engineering team is now. But for us, it's everything that we do is, most of our engineering work is done in-house, but we do have design partners outside of the company.
Are you optimistic about offshore power as a generalization? I mean, most of the people in the U.S. live along the coasts.
Yes.
So that's where the power is needed.
I think we're obviously very optimistic about it for a lot of reasons. It's a non-intermittent resource. There is some seasonality to it, but it tends to, in those areas where the wave resource is the strongest, the amount of energy coming ashore tends to match the load very well, so it's load matched.
What sort of swells do you need for efficient operation?
That's a good question. I think we try to have what I would say is an ability to operate in all sea states. So whether it's very low seas, as you might see in August, or even the roughest seas, as you might see in the dead of winter, we don't want to have to shut off in those very heavy seas. So I'm not sure I have an exact wave height that would be the optimal for us. I think what we're trying to do is design for operation at a maximum range.
Are you looking to site off beaches or off rocky coasts, or does it matter?
Doesn't matter to us.
Presumably it'd be easier in places where there aren't recreational beaches.
That's true. The grid interconnect, that line, that cable, that trunk line that's coming ashore, it's going to be buried. So whether it's a horizontal bore underneath the shore. So we're a little indifferent as to what the shore looks like. What we need is that grid interconnect substation. How
many of these wings have you actually put into the water and tested?
Yeah, so we have, we're on our third generation design. The first two generations did not use this winged feature. The third generation does. We've advanced that. It used to look like a circle, top down, the footprint. Now it's asymmetric. It's more like a box-shaped footprint. We have tested a number of them in the lab, in the flumes in the wave basin at Oregon State, and then this mid-scale prototype that I mentioned earlier. That's our mid-scale device that we put in the water. So we've had a number of them in the water.
Would it be right to assume that universities have really been a driver in the ocean technology for power, rather than government?
No, I don't know if I can say that more than government, but I would say that universities for basic research are critical here, as they are in the medical device or the biopharma industry. Without that base research, which is in large sense supported by federal governments, whether it's here or overseas, is a critical part of what's being done. I mean, our original license with Oregon State, that technology had been worked on for a number of years, 5, 10 years prior to. And so that is, yeah, you're right, it's an absolute critical part of what has to be done.
Reenst, good luck at Columbia Park.
Thank you very much.
Fascinating project.
I appreciate it. Thank you very much.
Super.